What's up, everybody? Hope you guys are doing well. It's Monday, and we got a little bit of magic. So if I take the number 2 pencil here, I just gotta give it just a little shake, and it's gone. A slight shake. Just give it.
Bobby Yamamoto.
Alright guys, so today we're looking at lesson 10.5, the effects of changing dimensions proportionally. So basically all we're looking at is what happens if I take a shape, calculate the area, perimeter, or circumference, and then change something about it. I could change the base, maybe I increase it by a factor of 2 or 3, maybe I change the height. What does that do to the area, perimeter, circumference? And then compare those two values. So our first example is what happens to the area of a parallelogram if the base is tripled. So I'm going to take my parallelogram here. I'm going to say what happens if I take the base and I triple it in length. So the base currently is 4. If I triple that, then that's going to be a length of 12 centimeters. So the new base, this would increase everything, something kind of like that. So what's the relationship, what's the proportion between this parallelogram and my new one with an increased base to 12? So that's what we're looking at. So really, this isn't too difficult to do. There's a few different ways you can do it. Obviously, we can look at more complicated examples, but let's start basic. So if I'm going to calculate the area of, let me erase some of this. Let's start with this shape. Just calculate the area of my original shape with the original dimensions. So the formula to calculate the area of the parallelogram is just base times height. So this will give me, the base is 4, the height is 5. So I get 20 centimeters squared. That is the area of my first shape. Now let's compare that to the area if I triple the base. So if I triple the base, again, that's going to be, area will be equal to, the base will now be 12. The height doesn't change. And that's going to give me, area is 60 centimeters squared. What proportion do I get there? Or what ratio, if I create a little ratio there, what do I get? So if I compare the area of my new shape over the area of the original, well, that is going to give me 60 centimeters squared over 20 centimeters squared. When I cancel out my units, 60 over 20 gives me 3. So my answer is that if the base is multiplied by 3, the area is also multiplied by 3, because 20 times 3 gives me 60. So that's the first way we could do it. You just plug everything in, they compare the relationship between those two numbers, the new and the old. Let's look at another way we could do this. So the new way I'm going to do this is, let's just compare our formulas here. So area new over the area of the original. Oops. We'll start with the original, base times height. Alright, so the area of the original is just base times height. The area of the new, well, I'm tripling the base, so I'm going to do 3b. 3b times the same height. When I cancel these, the h's cancel, my bases cancel, I'm left with 3. So the second way we did this, I didn't even have to plug in any of the values. I didn't have to plug in 4 or 5 or anything. I just used the formulas and just compared the change in the base. I just plug it right into the formula, cancel out like terms, I'm left with 3. So that's the second way we could do it. Also works fine. Example 1 here. Erase some of this. Alright, example 1. Describe the effect. When it says describe, this is basically what it's referring to. Is if the base is multiplied by 3, the area is also multiplied by 3. That's your description of the change. So describe the effect of each change in the area. Make sure you know what you're solving for. Here we're solving for the area of the given figure. So, example 1, the base of the triangle is multiplied by 2. So for this one, I'll do it both ways really quick. Let's start with plugging everything in. And we'll see that we actually run into a slight problem here if I try and do it the original way, the first way I showed you. So let's calculate the area of the original. I'm looking at a triangle, so it's 1/2 base times height. So we get 1/2 the base here is 3. Well, what's the height? We don't know what the height is. So that's going to be a problem. We don't have the height. So here we see that we actually have to use the second way I showed you guys. So using this second method, let's compare the ratios. So area of the new over the area of the old, or original. So comparing these two formulas, I get 1/2 base times height. The original one, right, original goes with this one. You take the original formula, and then the area of the new formula is going to be 1/2. Well, the base is multiplied by 2, so all I'm going to do is change this to 2b, 2 times the original base. The height hasn't changed, so I keep it h. Now we can look at starting to cancel things out. My h's cancel, my bases cancel here, my 1/2's cancel, and I'm left with the area. Come over here. Area is equal to twice. So the new area is twice the original. So the new area is twice the original area. And that would be my answer. You could also just say times 2, something like that. Alright, now let's look at example 2. Again, I would suggest that you guys pause the video, try this on your own. Just see if you can do it. But let's do this together. So, describe the effect on the area, changing the area. If the radius of the circle is multiplied by, that's a 1/2. So if it's multiplied by 1/2, I could do it where I plug everything in. Let's just go ahead and set up my proportion here. So area new over the original area. Well, the formula for the original area, I'm looking at a circle, so the area of a circle is pi times the radius squared. So when I compare the new area, pi times the radius was multiplied by that 1/2. So I do 1/2 r squared. Make sure all that's in the parentheses, 1/2 r squared. Well, simplifying this a little bit, this gives me pi, 1/2, do it up here, 1/2 squared is equal to 1/4. So I get 1/4 radius squared over pi radius squared. Pi's cancel, radius squared cancels, and I'm left with the change is 1/4 the original. And there is my answer. Now what would I get if I were to actually plug this all in? I'm going to erase this and see what I get if I actually plug the numbers in and see the actual areas. So let's calculate, for example 2, let's calculate the original area. So we get pi times radius squared, so pi 8 squared. That gives me 64 pi. Let's calculate the new area. Well, if it's 1/2 the original, it's going to be pi times 1/2 of 8 is 4, so I get 4 squared. So this gives me 16 pi. And then units squared. I just left off my units. Centimeters squared. Centimeters squared. So if I compare these two, area new over area original, 64 pi over 16 pi, well, that gives me 1/4. So I get the same thing regardless of which way I do it. I prefer this method here because you don't have to actually calculate any areas. You just basically cross out like units and you're left with the answer. But if you guys prefer this method, that's totally okay. You could do it that way. It works. Usually, as you saw previously, you might not have all the information to calculate the areas or whatever you're looking for. So on this example here, I actually had to do it the second method because I didn't have enough information to solve for the area, but I did have enough information to solve for the change in dimensions. So we look at this next box here. Let's say that we took a rectangle whose dimensions are length and width. That's our original shape. Length and width are the dimensions. Let's say I take the length and width and multiply it by a factor of a. Multiply by a right there. What happens to the perimeter and the area? When we look at this, if we're just doing our basic algebra, let's just plug things in. If I calculate the perimeter of the original one with just length and width, that would be the perimeter of the original. My new perimeter is I'm going to take the original perimeter and just multiply it by a. Because really what we'd be doing, this would give me P is equal to 2LA plus 2WA, running out of space, and then I factor out an A, factor out this A and this A, take it out, and I'll be left with this. What about the area? Well, the area is my original area, length times width. The new area, same thing. The new area would be length times a new factor of a, multiplied by a, the width times a. Well, this one it would give me L times W times A times A. Well, A times A is A squared, so this would be my new area. So that's just without any numbers. Again, you can kind of plug things in, just use algebra to solve for the new dimensions, the effects of the changing dimensions. Let's do 2 more examples. Example 3. Let's say that the base and the height of a triangle with a base of 7 inches and a height of 3 inches are both doubled. So the way I think the easiest way to solve this, let's do the area of, the area new over the area of the original. So what happens to the area? Let's check. Area. If the base and height are both doubled. Let's start with my original. So I'm dealing with a triangle. So I take 1/2 base times height. Well, my new area is still going to be 1/2 base times height, but my base is now 2 times 7 and my height is now 2 times 3. They were both doubled, each separately, each independently. I don't know why I plugged in. Let me redo this without the numbers. So base times height, 1/2. You could plug the numbers in like I just did, but since I kept the variables in the bottom, I'm going to keep it like that. 2b, 2h, yeah, that's going to be easier. The 1/2 cancels. I don't know why I plugged in the numbers. You could do it that way, but let's keep it with variables. So your bases cancel, your heights cancel. 2 times 2 gives you 4. So the change, your solution, change in area is an increase by a factor of 4 times 4. So the new area is 4 times the original area. Now let's do it the way I started doing it. Kind of messed up there. Area new over the area of the original. Area of the original. So 1/2, 7 times 3, and then 1/2, 2 times 7 is 14, 2 times 3 is 6. Well, that is going to give you 84 over 21 times 1/2 times 1/2. Those cancel out. 84 divided by 21 gives me 4. So you get the same thing. I could have done 84 divided by 2, 21 divided by 2, but I didn't want that decimal, so that's how you could do it that way. Let's do one more example. Checking the area. Let's take a circle that's a radius of 5 millimeters, and we take the radius and we multiply it by a factor of 4. Now again, you could plug in all the numbers to solve for the area. I'm just going to show you guys the way I would do it. Area new over area of the original. Checking the area. So the formula, pi radius squared for the original. For the new one, the radius is multiplied by 4. So pi times 4 times the radius squared. Make sure that whenever you multiply the radius, when you're squaring it, make sure it's in the parentheses, your change. Do not do this. Pi, and leave the 4 outside of the radius square. You have to square that 4 too, because the entire, so don't do that. The radius is multiplied by 4, then you square it. So don't make that mistake. Well, my pi's cancel. 4 squared is 16 times the radius squared over radius squared. Radius squared divided by radius squared cancels out. And you're left with 16. So my answer is the new area is increased by a factor of 16. That's your answer. Now you could also do this for circumference. I'll quickly do that. I don't want to go too long in the video. Just quickly do, let's say we had circumference for this one. It's the same process. Circumference of the new always goes on top. I think new is the best, so it goes up to the top. I don't know. Circumference of the original. Well, circumference is 2 pi r. 2 pi radius is multiplied by 4, so I get 4r. What cancels out? 2's cancel, pi cancels, radius cancels, and I'm left with 4. So the circumference would be increased by a factor of 4. So that's how you do the circumference. All right, one more example, then we'll be done. Let's say that a square has a perimeter of 36 millimeters. If the area is multiplied by 1/2, what happens to the side length? So I have a square, a terrible square. The perimeter equals 36. and we take the area, whatever that is, we can figure it out, since it's a square. Let's take the area and it's multiplied by a half. What happens to, if I take the whole area, multiplied by 1/2, what happens to my side length of the new one? That's the idea. So if the perimeter of my original square, PO for perimeter of the original, is 36 millimeters, let's find the side length. So the perimeter of a square is equal to 4 times the side length, so I get 36 times 4s, since you have 4 sides of equal length. So the side length is 36 divided by 4 is 9 millimeters. So if my side length is 9, my area of my original shape, 9 squared, 81 millimeters squared. That's my area of the original. Well, if the area of the original is multiplied by 1/2, all I'm going to do is for the area, so my new area of the new shape, is 81 divided by 2, which gives me 40.5 millimeters squared. Well, what if my area new, remember it's still s squared, well, my area is 40.5 equals s squared. 40.5 equals s squared. So all I have to do is solve. I take the square root of both sides. So my side length is now 6.36 round to the nearest 100 millimeters. So this is my new side length. This is the same thing as 9 over root 2. So how does the old side length, SO for old side length, compare to the new side length? Well, the original was 9. The new one was 9 over root 2. So if I take my original and multiply it by 1 over root 2, that will give me my new one. So the original side length is multiplied by a factor of 1 over root 2. And there's your change in dimensions. Alright, hope that was clear. Email me if you have any questions. See ya.